Cool. Okay, recording is going. And let's just get to the session for tonight. And tonight we're going to look at study unit 9, so hypothesis testing. And then on Sunday, what I like to do is that we cover both last two sessions, study unit 10 and 11, so that when in the week of next week, we can look at all the study units and just focus on previous exam papers. It will be anything from study unit 1 to 11 in any format. Okay, so let's get into study unit 9. Okay, so what I've done is, and you guys will see it now in this session tonight, there's been, so I think this is from last year, then I've combined the last 2 or 3 years different questions. So you would see certain things coming through. So I'm just looking at this one. So there was the hypothesis, then they changed it a bit. So these was things on its own. We will get to it, but then here's a question, very similar question that they then ask in another year. So you can see that's 2021. Then very similar in another year, 2 or 3 questions. So it seems to me there has been in the last 2 or 3 years been quite a number of questions that they've reused. So it will be of benefit, and that's why I'm just going through examples and examples. And when we go into the exam prep, the nearly looking at going through a paper at a time, that will just give us more and more problems and things that you can have a look at. Because again, what I've seen, there can just be so much questions that they can really ask. Okay, so let's get into this one, and let's see what they ask us. So a sample of 36 with a sample mean. It's also known that the population standard deviation is 16, but look at that. Population standard deviation is known. So we know that we're going to work with a Z in this one. Then they say you are required to use the information to test the following hypothesis. Okay, so yeah, so that is nearly what I was thinking as well. So I'm looking, when I look at hypothesis, there's a few things that is for me always important. So I look at the first thing is, so here we know it's about the sample mean, but I want to check, is the population standard deviation known or unknown, so that I can work with a Z. So that's the first step I will look at. Then the next step is inverse hypothesis. I look at the alternative so that I can see if it's a one tail or two tail. So that's nearly the second step. Then I'm looking at this and I'm seeing, okay, they don't give me to say I'm testing it at 95, 99, 90, or then the inverse at 1, 5, or 10% level of significance. So that will most likely be in your question set. So here we can see they put it in the question set. So normally they can add it into the steps that we nearly need to cover. Are we looking at a 1, a 5, or 10% level of significance? Else it must be in a specific question. And sometimes they then give you what, so in this instance, because we don't know what level of significance is, we don't really know what the critical value is. We will be able to work out the test statistic, or the test Z as I call it, because we will know this component. So that will give us the test Z, but they don't give us the critical value. So the critical value we can only find out if they tell us the level of significance. Okay, so that's nearly the things that we need to look at. Okay, so then basically when you get this, how I would look, I would read first all my options. So I would look at it and say, by looking for incorrect, okay, test statistic, okay, we can work it out with that. So that might be a simple one. An upper tail test is applicable. Okay, so you can tell me about that. At a 1% level, we will need to look what is the p-value. The p-value is that, so that is linked to the test statistic. And at 1% level, null hypothesis. So again, we will need to look, if we have that, what's the critical value? Okay, so for me, option B is the first one that I will look at because there's nothing I need to work out. So would you have said that's correct or incorrect? So are we working with the upper tail Z or are we working with the lower tail Z? And so what are the other guys saying? Okay, so here it is smaller. So we are working with a lower tail test, okay, because they tell us the mean is smaller than 80. So that tells us we're looking at the lower tail. So that one is actually the incorrect one, which then makes this question much shorter than you now need to work out everything. We are going to work out everything, but in the exam, rather read through the options um, so that you don't need to work out everything. Because again, working out the T-stat, it's not difficult, but it takes time. So let's work out what Z is. So Z is equal to 86 minus 80 over, what is the standard deviation? 16 divided by square root of 36, which is luckily a nice number. So that is going to be 6 divided by 16 divided by 6. That is going to be around 2.66 continuous. Okay, so the Z value is 2.25. So that is correct. So let's get, let's, since we now have that Z value of 2.25, let's work out what is the p-value. And because it's one directional, it is only this side, it's not equal to, so it's only the one side. So let's look at what is that p-value. So let me quickly get into the so that we can quickly go to the p-value. Strange that I first need to upload that, but it's fine. It will. So again, I would, and to the point of the steps, I would nearly, as I do the T-stat, because I get the 2.25, I will look in the options if they ask something about the p-value, because that's nearly, those two goes together. The same with the level of significance goes together with a critical value. So those things I would nearly partner up with when I am looking at the solution. So let's just see when this now finally is downloaded. Sure, it is taking time. My network is very slow today. Oi, okay, so while we look, that is downloading. Okay, cool. Yeah, we go. So let's quickly get into the Z of 2.25. So again, it's easier to get to the negative one. So minus 2.25, 0.0122. So that p-value is 0.0122. The p-value is 0.0122. Okay, so that those two are linked to one another, the t-stat and the p-value. So that's nice. We've now covered those two. So let's go to the level of significance. So at a 1% level of significance, the rule is to reject the null hypothesis if a p-value is greater than or equal to 0.01. Okay, so that is true. So we will accept the null hypothesis if it is within. If it is outside, we will reject. So, and then at the 1% level of significance, null hypothesis is not rejected. Okay, so at 1%, so let's quickly look at a null hypothesis is not rejected. Okay, so here we work with a p-value is greater than that. And so let's quickly look at what is that value. So that should be 0.99, which is going to be bigger. So let's just want to make 100% sure that we're now doing this correctly. 0.99. So it will be somewhere there. Hmm. Oh, sorry. If you look at, so what they, so here they're saying at the 1% level, the rule is to reject the null hypothesis if the p-value 0.0122 is bigger than 0.01. I'm now wondering about this one as well. So let's quickly write it just down how we would do it. Again, I'm now getting confused with all the wording. So let's check that is 0. Z, so if my, so this is the Z test, and then we have the other one that is the one with a level of significance. So that one was 2.25. So if it's lying to this side, I will accept H0. If it's lying to this side, I will reject the null hypothesis. Okay, so that means at a 1% level of significance, the rule is to reject the null hypothesis if a p-value is greater than or equal to, so it is, you will reject the null hypothesis if that p-value is actually smaller than 0.01, because then we will accept the alternative. So this one is actually also, that one is correct, but this one is also incorrect. So let me, okay, thank you for that. P-value smaller than that, yes, when we reject the null hypothesis. P-value bigger than that, so 0.0122 is bigger, so we do not reject the null hypothesis. Thank you. Okay, so that's why I said this one feels wrong, option C. Let's put this cheat sheet in here, you guys, because it's always, I now needed to go and draw it again unless I have it in front of me. An upper tail Z is applicable. And so that is also because we are looking at a lower Z test. Or do they mean that? Let's quickly check the other one. So here, bit of information different, incorrect. So incorrect. So here the upper tail test, which is an upper tail test, that would have been correct. And so I think what they did here wrong is they mixed up this question because both B and C is wrong. So that tells me it's a lower tail. I think they messed this up a bit. And here we see if a p-value, and the p-value is 0.0122, if that is bigger than the level of significance, which is 0.01, because it's 1%, we do not reject the null hypothesis. So E is correct, but C is incorrect. So there are two in this one that is actually incorrect. So again, if something like this happens in the exam, you let me know, because here we can see, here we are looking at a bigger than, so the upper tail test is applicable, which is correct. So yeah, so definitely in the previous one there was two that is wrong. So please, if something like this happens in the exam, you let me know, because one can see they used the previous exam paper or previous quiz and did not change all the information. So again, what we will check here is, firstly, are we working with standard deviation known or unknown? So is the sample with a mean. It is also known that the population standard deviation is known. So again, we work with a Z. So very similar type of question. So again, I would have looked at it and okay, that we will need to work out with a Z. Those two are linked, so we can see those two together, and then we're going to look at the level of significance, and those two are, are then linked as well. Okay, so let's work out the Z test, because that we basically need to know what the Z value is in any case. So Z is equal to, and we know its standard deviation known, so we can use that one. So now we'll suddenly see where the other one was 86, where it became, now we have 83, so it will be a bit smaller, but still not negative, but still, sorry, 16 and not 36 divided by 16, 16 divided by square root of, so that stayed, the bottom part, the mean stayed the same in both. It's just the sample mean that have changed, and now it is still 16 divided by 6, and that multiplied by 3. So I get that our t stat must be 1,125. Okay, so that means option A is the incorrect one. But again, let's look at the p-value. So 1,125. Let's look at the p-value. Minus 1,125. Wait. 1,125. So that will be 1,13 if we round it off, or we can check between 1,12 and 1,13. Okay, so 1,1, 1,1, 1,1, 2, 1,13. So it will be interesting if they add those two together and divide by 2. So let's look at if it's 1,1314 plus 1, sorry, 0,1292. So let's see. So we're looking at 1,125, 1,125. So 25 is in between those two. Let's see if they do it as 1,1314 plus 1,1292 and divide by 2, we will get 0,1303, 0,1303. Okay, so what they basically did was to say we add the 0,1314 plus 1292. And then we divided it by 2. Okay, so again, this is one of those weird ones, because if it was 1,127, we probably would have rounded it off to 1,13. So very one of those that you don't always know, must you actually add the two together, divide by 2, or do you round it off and then get a number? So not a nice one, but basically if we add it with 2 divided by 2, we will get the p-value. And when we say at a 10% level of significance, the rule is to reject the null hypothesis if a t-stat is greater than or equal to. So if your t-stat is greater than that, then it lies outside. So then, very similar to that cheat rule, if it lies outside, we will reject the null hypothesis. So here we go with the assumption that you are looking at a critical value of 1,285, and then at a 10% level of significance, the null hypothesis is not rejected. So now we need to check what is that. You can, with the p-value, already see the p-value is bigger than the 10% because 0,13 is bigger than 0,1. So with a p-value, we could already say that we do not reject the null hypothesis. But let's see if we can get 10% level. So that is, on this scale, it would have been 0,9. So let's look 10%, 0,9, 0,9, 0,9. Okay, so it's somewhere here. 1,2, 1,28, 1,28. See, so again, this is now interesting. Why do I not get the same? Let's quickly check if I look at 10% on this side. 0,1. Oh, okay, so obviously, so it lies within. So I'm now looking at something that, so if I look at this one, it lies within, so that is why I will accept the null hypothesis. It's not that it lies outside of it. So your t-stat that we worked out lies within that critical value. So that is why we reject. So if, again, so there is, I know I've written this in one of the cheat sheets as well. So it's basically just the opposite of those that, so I will just get you again the right one before I now confuse the situation. But it is exactly just the opposite of the p-value. So the one we worked out is within that limit. So that is why it is like that. So I will just get that for you again, that we have all of that on one page. What I will again share with you guys as well is my study notes. Let me quickly, it might not be that all of you have it, so I just want to quickly see. So while that is downloading, I have made notes. So, and one of it is where I have also put this down. If your test value is smaller than your critical value, we accept the null hypothesis. So I will quickly show you guys, and it might be that some of you haven't received it. So I will tonight, when I put on the link to the recording, I will add this for you as well. So it is here, you can see. So basically, if a t value is bigger than the critical value, we reject the null hypothesis. And if we look at it from a p-value point, that's what's happening. And if we do it the other way, the test value is smaller than the critical value, we accept the null hypothesis. That's what happened now, but that will also mean that your p-value is greater than that. Okay, so I will share this again, because this is also nearly the critical value is the one that goes with the level of significance. Okay, so yeah, and that we will read off the table 100%. So that we will read off this table, where the t-stat is the one that we have calculated. Yeah, so that level of significance, the 10%, we got it as 2 point something. So that, again, the 2 point something of the critical value is, so the t value that we add was 1,125. That is smaller than the critical value of 2,28 or whatever it was. So that will mean that we accept the null hypothesis, which also means we have seen that the p-value of 0,13 is bigger than the significance one of 0,1. So those two normally is also go hand in hand. So when we can look at, so I now said we can look at it this way, but you can also look at it, the p-value and the 10%, and here we now not have that critical value, but the t compared to the critical value. So that is, so there are few angles in this that you can nearly cross look at it to see where you want to say which one is wrong and incorrect. So that sometimes you don't need to nearly calculate everything, because here, okay, we calculated z. With a z, you can get to the p-value, but then you can already compare and say, well, that p-value is bigger than the 0,1 because that's 10%. So that already means to me that I'm gonna not reject the null hypothesis. So that you can nearly already then tick off. We didn't even need to know what the critical value is or go and look for it. You could have done it by just looking at the p-values. So there is sometimes shortcuts in it, but it's not always nearly there to see it from the start. It's now afterwards that that I also have now seen. Okay, cool. That makes sense because that makes sense. So nearly, it's not always from the start that one can identify the links between the different things. But again, I think as we work through examples, it does become clearer. Um, so let's look at another one that was in the 2021 assignment. So suppose the calculated t-stat for one-sided, and they tell us lower tail is minus 2,74. Suppose further that the population standard deviation is known. So that means we can work with a z. What is the p-value of a test? Okay, so we basically need to look at z 2,74 and one-sided lower. So we want to basically know what is the z smaller than 2,74. Okay, so z, not minus 2,74 minus 2,7, 0,0031, 0,0031. Okay, so there it is correct. If it was two tail, we need to, so that's for one tail. If it was two tail, we needed to multiply by 2. So there is our answer for the two tail as well. Okay, so just again, very important, because we know some of you guys might get the one tail, some might get the two tail in the question, or what they might do is instead of 2,74, let's just quickly see. We've now seen the 0031. Let's see what is 0024, because 0024, let's just quickly see if there was. So then they might have said to you minus 2,82. So it might have been that the question then is minus 2,82, and that would have given you that 0,0024. So again, because there is 2 or 3 different questions per question that you nearly get, it might just be that they change the value of the z to give you something that looks different. So again, just be on the lookout for those kind of things, because again, you basically just remember that you're working with your paper and there are a few different questions around. So then they ask, so somewhere we know they need to ask the unknown question as well, because so when we do hypothesis testing, remember that's nearly like study unit. Oh, the one before this, the confidence intervals. We nearly know we need to get a question where we're looking at standard deviation known, standard deviation unknown, and a proportion. The same with hypothesis testing. We will get one where the standard deviation is known so that we can work with the Z. We will get a question where standard deviation is unknown, and then we need to work with a T. They don't need to be so specific to say that you're working with the degrees of freedom. So when I look at this and they say degrees of freedom, then you automatically go to T, but they could have said to you, if a population standard deviation is unknown and you're working with a sample of 26, what is the critical value for the test? Okay, so they don't need to tell you that you're actually working with degrees of freedom. They could have just said sample is 26, but you would have, out of the unknown component, would have seen that you're working with a T. Okay, so T25, two-sided hypothesis, so 0,05, two-sided, so we still need to divide by 2. So we're actually working with a T of 25 and 0.05 divided by 2. Right, I just need to check my calculator for this one. Sure, okay, so T25, 0,025. So let's T25, T25, 0,05. So we will go across and up. So 2,0595, 2,06. So that is rounded off what we would have gotten. Okay, and that is when, because it is two-tailed, two-sided, it is plus minus. But they will not, I don't want to say not, but not really will give you a plus minus 2,06 and somewhere else just have a minus 2,06 and somewhere plus 2,06, because that nearly gives it away that your answer is 2,06. So they will not really do that. The reason for the two-sided is more for, sorry, I didn't want to do that, is to use it in this component so that you needed to get to a 0,025. Because I'm sure if we used 0,05, let's quickly see, 1,71, there was an option of 1,71. Okay, so the two-sided here is more that you know that you need to divide that 5% level by 2. If you did not, and you used just 5%, you would get that answer. Okay, so just be, again, very careful with what is in the answer set, because if you just use the 0,5 and not divided it by 2, there is, unfortunately, an answer for you as well. If you use Z of 95, there would have been an answer for you as well. So if you still did not incorporate the degrees of freedom, but went to a Z because of a 5%, there is an answer for you as well. So again, just those small things that kind of play an impact on your answers. Okay, so next one, and let me just crop this a bit. And again, we have this as repeated in another year. So you could see very similar question. The thing that has been changed is the 85. We still have 200. Look at that 78. So there's still your 78. There's the 200. So the only thing that have changed in the two questions, at least the name has also changed, but that is exactly, and then they also ask you the 5% level. So very similar questions in two different years. So let's see what we need to get. So most of the schools reported a decline. Sample of 200 schools, 72% reported a decline. The district manager is adamant that the true population proportion is 78%. Formulate the null and alternative hypothesis and conduct the hypothesis test for the true population proportion. Okay, so they say the district manager is adamant that the true population proportions of schools that reported a decline in the number of absences is different. Okay. We're not saying more, we're not saying less, it's different. Okay, so what we are then looking at is that the proportion is equal to or not equal to, because it's different. If I said it's bigger than, it would have been a bigger than, smaller than, it would have been a smaller, but this one is just different. So let's look at what the other one was also different. So it's not bigger, it's not smaller, it's different. Okay, so which of the following statements is incorrect? So let's first see if there's not a statement around for alternative or the null hypothesis. So that is always the first thing I will check, because they said we need to formulate it. Feels like there needs to be something. Okay, p-value, we will need to work out the z. We can conclude that the proportion of schools have reported a decline in number. Okay, so we will need to work that out. The alternative hypothesis is that the population proportion is not equal to, okay, so that one is correct because we've seen it's not equal to. The null hypothesis is rejected. Okay, we will need to work out. And there is also the test statistic that we will work out. So A and E will again be linked. So let's just on this one, it would have been exactly the same. So the null hypothesis is, sorry, that should be null hypothesis and not that, is equal to 0.78, and the alternative hypothesis is, because they say different, not equal to 0.78. So the first one, the alternative hypothesis, is that the population proportion is not equal to. Okay, so the same answers set in both. Then, okay, we're going to look at if what the null hypothesis is in conjunction with the level of significance, the p-value, the t-stat, so those two also goes together. So the rest we will need to work out. So to get to the p-value, we need to get the z. So let's get to the z. Remember, this is proportion, so the proportion formula, let's quickly see, have I written it down somewhere? Doesn't seem like it, but let's just look at what we did in study unit 7 and 8, because that will be exactly the same. So where is my cursor? There. So there we go. That will be the formula that we will use to work out the z. In and the square root. And because that is similar for both questions, we are gonna just use it in both. So let's first work out, this one is 0.72 minus 0.78. Okay, that's interesting. So that is going to be negative, actually. So 0.78 times 0.22 divided by 100, square root of that. So we're going to divide by 0.0414. So in this instance, now that is, what is that? Negative 0.06. So let's divide those two. So okay, so let me just check this again, because then I get that is wrong. So 0.72 minus 0.78, it is 0.06. And if I divide that by 0.0414, I get minus 1.45. So please just check if that is correct, because that means that is the incorrect one. If I go to minus 1.45, the table minus 1.45 minus 1.45 minus 1.4, 1.45, 0.073. Okay, so that, thank you, because that did not feel correct. Okay, so let me just quickly calculate that again. It just did not feel correct, so that's why. Oh, I okay. I divided it by the wrong n. That is why. Let me quickly see now if this is. It just felt wrong. Thank you for just confirming that I was wrong. Yes, minus 2.048. So your t stat is still wrong, because it must be negative and not positive. But at least now we're looking at minus 2.05 minus 2.05 is 0,0202, 0,0202, but because of a t-tail or two-tail, we multiply by 2. So that will give us the 0,0404. So that the p-value is correct, but the t-stat is the one that is incorrect because it's negative 2,05 and not positive 2,05. And then let's just see. So now that we have that, 2,05. Let's just see. So we can conclude that the proportion of schools that reported a decline in the number of absences is significantly different from that. So again, let's check p-value. P-value of that is smaller than the 5%. I'm going to shift this now. Let's just quickly, let's take that away and just write it at the bottom. So that is smaller than 0,05. So let's see from that cheat sheet that we have. So if a p-value is smaller than the alpha, we reject null hypothesis. So we can conclude that the proportion of schools that reported decline is significantly different, and the null hypothesis is rejected. And so both of them are correct. So we reject the null hypothesis. So we accept the alternative. The alternative says there is a difference, and that is what it is saying here, that we conclude that there is a difference. Okay, so this one was now just the opposite, where we can say the p-value is smaller than the alpha. Because of that, we do reject the null hypothesis. Okay, so here the t-stat was the one that was incorrect, because it is actually negative and not positive. So let's, for interest's sake, we are now going to go through this. So here the proportion one, so here it's going to be 0,85 minus 0,78. So that is going to be a positive. So that t-stat might be right. I just want to use this 0,2929 because that is, in any case, what we have. That didn't change. 0,02929. So let me just use that. So let's quickly see what that would have been. 0.85 minus 0.78. 85. My calculator, I think, needs new batteries. Okay, so I get 2,389. So that is 2,39. So that is correct. Then if we go to get the p-value, 2,39, So let's see what that small area is. It's the same on this side, so I can go to the negative table rather, minus 2,39, minus 2,39, so there it is, 0,0084, 0,0084, but remember that is only for that area. We need to multiply that by 2 because there's 1 there as well. So that one will actually be incorrect because it is 0.0084 times 2, which will give us a right answer of 0,0168. Okay, so that is the wrong one, the p-value, because again, not equal means that it is two-tail. Two tails mean on the one side, we've got the 0,0084, but there's 2 of them, so it is multiplied by 2. Okay, so that is the p-value, and then from the p-value, let's quickly see then it is probably around the hypothesis. So with this, we can now say, okay, 0,0168, that is 0,0168, that is smaller than 0,05. So let's again just check if it's smaller than, reject null hypothesis. The null hypothesis is rejected, which is correct. If a null hypothesis is rejected, the alternative hypothesis is true. So that means that we can conclude that the proportion of schools that reported a decline in the number of absences is significant different because it is not equal to 0,78. Okay, so that will then also be true. Okay, so nearly again, we had the two very similar questions. The incorrectness nearly came in the one where the t-test was wrong, and in the other one was that the p-value was wrong, where it should have been a two-tail and not a one-tail. And what I've seen with these types of questions, when the test statistic is wrong, it's normally just wrong. It's not, so it is because somehow they make you feel it's the swapping of the numbers sometimes, where was it here, 1,285, so it's nearly something that is very close to that one, or it will be that it refers to the negative or the positive, or it will be when it's the p-value that, or they give you a two-tail and you want it a one-tail, or they'd sometimes give you the one-tail and you want it the two-tail. So that's nearly where it's most of the time wrong. Because if you look at these ones, you could have nearly seen, okay, if a null hypothesis is rejected, that means that the things are different. So for those both to be unequal, we they needed to be having that you need to pick the correct one nearly. So there is sometimes some of the things that is it is nearly in a sense being given away because all of the things can't be suddenly wrong. So there are that connectedness between some of the answers as well. So this again, we can now quickly look at the two different years that this was in. So basically looking at information of how many words per minute kids are reading. And you can see now suddenly all the all that changed is grade one teacher and not a grade two teacher, but basically sample sizes have changed a bit. The standard deviation with the speed is a bit different, but all the rest are very similar. So all the rest are very similar. So let's read it and then let's see what they want from us. Um, so literature group recommend that the reading speed is 119 words per minute. Grade 2 teacher is convinced that the average reading speed for her class is different from the recommended speed. In a sample of 37 grade 2 learners, the average reading speed is 110 with a standard deviation of 21. You are required to test the teacher's hypothesis at a 5% level that a grade 2 class speed is different from a recommended speed. Okay, so then we get options. We do not reject. There is not enough information. Okay, so that is there's not enough information provided to decide and conclude about the. This is a strange question. There's not enough information provided to decide and conclude about the null hypothesis and alternative hypothesis. Okay, so there is enough information. So that is actually incorrect, but it's not supposed to be seen as that. I just want to see again. Okay, there it was correct statement. Here it was incorrect. So there they mixed it up and it was wrong because here there is not enough information is wrong because there is enough information. So again, you can see they changed it between years and did not see that because they now changed it to incorrect. That one is actually incorrect. So this student was actually correct in saying that because there is not enough information is incorrect. But that's not what they wanted out of it. Okay, so again, if something like this happens in the exam, please, because you can see this has not been set up correctly. They just changed certain numbers and things and did not change the answer set because that's actually right. It is incorrect. But let's just see what else is actually incorrect. So rejecting, not reject, reject. So we actually need to work out the Z so that we can say what is the Z value. We might go and find the p-value and compare the p-value to the 5%, and then we can decide. So let's just see, is it a Z or a T that we're working with? Various literary group reading speed of that. The average reading speed with a standard deviation. So this is actually doing a T. So let's just check. We are gonna work out the T, but that is fine. When we do the T, we are using the same values. So we're using that. The only difference is we write it as S divided by N, but we are actually working out a type of Z answer. So let's quickly just see X minus me. So 111 minus 119 divided by standard deviation of 21. Okay, this is going to be a weird number because we're dividing by 57. So this answer that we're getting is 111 minus 119, so minus 8 divided by 21 divided by 37, the square root of that, which I nearly get as, I'm going to round it off a bit now, so 3,45. So if I work that out, I get minus 2,32. Okay, so just check for me if that is what you also got. So then we'll check at yes, yes, yeah, that is perfect. So if I said known population, we will work with a Z because by talking here specifically, and they didn't really say unknown, but they said in a sample, the standard deviation is. So what we know is the sample standard deviation, and we don't know the population standard deviation. So they can, like one of the previous ones, they can tell you straight up the population standard deviation is unknown, or they can hide it a bit by saying the sample is this with the mean and standard deviation. So then you know it's the sample mean and the sample standard deviation, which then means that it is unknown, the population standard deviation. Okay, so that's the important link. We will nearly get to the same answer if we have used, because you work the T, and to work out the T and the Z is exactly the same. So you can see this formula is exactly the same if we would have used the Z, but when we're going to test it, we need to test this number against a T value, which would then be 36. And remember, we're using two-tail because they say it is different. It will be the 5% divided by 2. So, and this is probably out of your hypothesis testing, the most difficult question that you will get. Because you needed to see that we're working with a T. Nowhere in here they mentioned a T at all. Nowhere in this they mentioning a T test. So you needed to nearly know that you need to work with a T. The T to work it out and the Z is exactly the same. But when we're going to test it, that's where the difference comes in. So the T at degrees of freedom is 36, and that is 0.05 divided by 2.025. So let's quickly see what if you would have made any different calls if it was a T or a Z. So 36. Okay, so obviously I used this one at the stage for this one, 36 of that 2,0281. So 2,0281. So let's draw it in here. It's very small space. But so there is your 2,32 negative. But remember, we know it is two-tail. So there's a 2,32. That lies within that area. So you see that lies within the area. So we would have said in this instance, okay, your critical value 0,02 is smaller than your T-stat. Sorry, blank there for 4 minutes. So have I closed? No. So let's see your T-stat. Your T-stat, there we have it, 2,32 is bigger than your critical. So T value bigger than critical. So we reject the null hypothesis. This just T value is bigger than the critical. T stat is bigger than the critical because that's the critical. So there's your T stat. Bigger than your critical, so we will reject the null hypothesis. Let's just see what your p-value, that's going to be now difficult to get a p-value for the t of minus 3,28. Let's quickly see if we can minus 2, minus 2,32, minus 2,32 or 2,32 at 56, 2 comma, so it's going to be somewhere between those two. So our p-value would have been, so that becomes smaller. Our p-value would have been smaller. So let's go to that one again. Our p-value would have been smaller. So we would have rejected the null hypothesis. The same, we now say our t-stat is bigger than the critical, so we reject the null hypothesis. So again, I think this is one of the most difficult ones that you will get for hypothesis. If so, let's see. We do not reject. Okay, incorrect. We reject. We do not reject. Okay, so we reject the null hypothesis and conclude that grade 2 average reading speed is not significant different from that. Was where we do not reject the null hypothesis. And so your null hypothesis is that the reading speed is the same. Alternative hypothesis is that it is different. We reject the null hypothesis and conclude that grade 2 reading speed, so that's also, so there needed to be, okay, I'm going to take this one out because there's too many mistakes in this question. We do not reject the null hypothesis and conclude that grade 2 average reading speed is significant. So that tells me it is significant different. We do not reject the null hypothesis. Okay, so there must have been another option because now we're getting two mistakes here because we do reject the null hypothesis but rejecting the null hypothesis, we accept the alternative. By accepting the alternative, it tells us it is different. So it is significant different. So definitely there needed to be another option that I did not include because we reject and we say that there is a difference. So let's quickly see when we work this out, it is probably what we want. So here one can see when we work it out, it's going to be we reject the null hypothesis. Sorry. Okay, so let's quickly see in this one nearly the same things that they tell us, but look at, I want the correct one, and look at this, that you are required to test the teacher's hypothesis that his grade 1 class reading speed is less than. Okay, so the alternative hypothesis is telling us it's less than. So we would do exactly the same. Let's just quickly see if they tell us again sample and then the things around the sample. So various literacy group, so it should be 82. I say the teacher says no. The average reading speed is 77, which then she says, or the teacher says, sample of 32 grade 1 learners, average reading speed is that. So sample, standard deviation is that. So again, because of the word sample, it is a t that we are going to work out again. It's 15 divided by the square root of 32. So that would have been, let's just quickly see, 77 minus 82 minus 5 over 15 divided by, calculator is struggling. Yes, so just please check that I'm working it out correctly. I've got that I must divide minus 5 by 2,65. So that what I get is minus 1,89. Okay, and when we're going to check the degrees of freedom. So for our critical value, it is going to be degrees of freedom of 31 against the 5%. So again, 5%. So now you guys must tell me, is it 5% or is it 0,025? Because that will give us two different answers. So let's quickly see. It was degrees of freedom 51. Degrees of freedom 51. So if I go at 0,05, I get 1,69. If I go at 0,025, got 2,02. Okay, so that makes a difference. 2, what did I say? 2,04 versus, and it will be negative, versus the other one is 1,69, so 1,70. So let's just round it off. Versus 1,70. So if we say the t-stat is bigger than that we worked out is bigger than the critical. So if that is bigger than that one, we will reject the null hypothesis. If that one is smaller than that one, we will accept. So let's quickly see. That is with 0,025 significance, and that is with a 0,05. So one tail means that we are working with a 0,05. Okay, which makes that the one that we're looking at. So your t-stat is bigger. Because it's bigger, we reject the null hypothesis. We accept per alternative. Alternative says that the reading speed is less than. And option one or option A is the correct one. If we used it as a two-tail, we would have said, no, but I accept. We do not reject the null hypothesis. So we do not reject, and it is not significant. So then we would have had option E, because then we would have said we do not reject the null hypothesis, and it is not different because it is equal. So then we would have had option E, which is then actually correct, but it is because we're doing the wrong thing. So it might be then like it was in your assignments that you, for that one, you get 4 points. If you set E, you might get 2 points because your process was right, because they can definitely see out of you going for E that you did follow the process right, but in the end you used a two-tail instead of a one-tail. If you said we reject the null hypothesis, which is also correct, but not significant, they might actually give you less for this one than E, because here you made another mistake, and that is having your hypothesis wrong. So again, it might be that you've done everything right. Your mistake was using two-tail instead of one-tail, and that is maybe not as bad as getting your whole hypothesis wrong if you're looking at something like answering it B and D or something like that. Okay, but this one was really, if you look at, we'll get now to that one, but if you look at these two, for me, this is the most difficult of your hypothesis testing, because here you again can't really, with, if it is a Z, you can play around with the p-value and the t-stat to see if you accept or reject. But if you're working with this, I now looked at the p-value and said, well, yeah, it needs to be between those two, but I can't really with certainty know what it is. So that's why it makes these two really difficult, because it it is just by looking at the t-table and getting the two t-values that you can make this call, and make the right call. So that's why this for me is one of those, the most difficult in my hypothesis. Then the last one. So here they tell us in a sample of 100, the sample proportion is this. Consider the following hypothesis test and calculate the p-value. Okay, so automatically that tells me one tail. So when I look at this, you guys know me by now already. I look at shortcuts. So I'm like, okay, if I take that, okay, that and that is double of one another. So if I would have guessed, I would have probably gone there. Those two are not double. Those 2.0688 times 2. Okay, doesn't give you that. 0.1251 times 2, 0.2502. Okay, so that those two feels very nice. But if you double up, so I would have automatically went to guess that. But let's see. So I need to get a Z value. So 0.4 minus 0.32 divided by, and now we need to do the 0.4 times 0.6 divided by 100 calculation. So hopefully I'm not making mistake with this one. 0.4 times 0.6 is equal to 0.24 divided by 100, 0.024, the square root of that. So that would have been 0.08 divided by 0.0489 rounded off. So that Z is equal to 1.63. Okay, so then this is interesting. So let me just, so then I would have nearly looked at 1.63, and I need to see the p-value. So let's hope 1.63 represents one of those two. Negative 1.63, negative 1.63, 1.6, 1.6, 3, 0.0516, 0.0516. That is the one that we are looking for. We don't need to multiply by 2 because it's one tail. If you've multiplied by 2, you would go for that answer, which is wrong. Okay, so just showing again that there is nearly that option also for you guys to pick wrong if you have gone for the two tail, unfortunately. And that is it. So I will look for more of these type of questions, so that I can just see um, for that. Yeah, is I see a hand, so let me just stop the recording so that I can load it still tonight for you guys.